Tonight, the moon waits where it always has, suspended in quiet companionship with the earth, asking nothing of those who look toward it. There is no need to hurry anywhere this evening. There is no mystery that must be solved before morning. No race to understand every crater or every mountain before sleep arrives. The moon has remained patient for billions of years, and it is content to let its story unfold just as slowly. Long before any telescope was lifted toward the night sky, people noticed that the moon carried shadows across its face. Those darker regions seemed almost familiar, as though someone had brushed soft gray paint across an otherwise bright surface. Some imagined seas, others imagined forests, valleys, or distant lands where unknown creatures wandered beneath another sky. Even now, knowing far more than our ancestors did, those broad dark plains continue to invite quiet imagination before they invite scientific explanation. The gentle truth is that these dark regions are not seas at all. They are enormous plains of ancient volcanic rock, spread across the moon after immense eruptions billions of years ago. Their smooth appearance comes from vast floods of molten basalt that slowly filled giant impact basins. Over countless centuries, these cooled into broad, level landscapes that reflect sunlight differently from the brighter highlands surrounding them. If one could somehow stand there, safely sheltered against the airless silence, the surface would not resemble the calm water once imagined by ancient observers. Instead, it would stretch outward as an endless plain of gray dust scattered with stones, softly rolling beneath a sky that never turns blue. There would be no breeze to carry away footprints, no birds crossing overhead, no distant sound except the quiet rhythm of one's own breathing inside a spacesuit. There is something comforting about learning that one of humanity's oldest misunderstandings has become one of its oldest scientific lessons. Sometimes the universe allows us to replace myth with understanding without taking away any of the wonder. Slowly, our attention drifts toward one of the moon's oldest features. The oldest visible landscapes on the lunar surface formed more than 4 billion years ago, preserving a record from a time when the young solar system was far more crowded than it is today. In those distant ages, countless rocky bodies crossed one another's paths. Asteroids and fragments left over from planetary formation traveled through space on unpredictable journeys. Many eventually struck the moon with unimaginable force. Each collision released tremendous energy, carving circular basins and sending pulverized rock outward in graceful arcs that eventually settled back onto the surface. Unlike Earth, the moon possesses almost no atmosphere and no flowing rivers. Rain has never fallen there. Wind has never whispered across its valleys. Oceans have never worn its mountains smooth. Because of this extraordinary stillness, many ancient impact scars remain visible after billions of years, quietly preserving events that vanished from Earth's own changing surface long ago. Our own planet has always preferred renewal. Continents drift, Volcanoes reshape landscapes, glaciers advance and retreat, forests grow where deserts once stood, and oceans slowly erase the marks left behind by time. Earth is wonderfully alive. The moon, by comparison, remembers. Its silence has become a kind of archive, holding stories written in stone that our own world gently forgot. Far above those ancient plains lies a fine blanket of dust known as regolith. This powdery layer covers nearly the entire moon, formed through billions of years of tiny impacts. Even the smallest particles traveling through space possess remarkable speed. Grains no larger than sand strike exposed rock over immense spans of time. Each tiny collision shatters minerals, producing ever finer fragments until the surface becomes covered with soft dust several meters deep in many places. Walking there would feel unfamiliar. Every step would press gently into loose material that has remained undisturbed for ages beyond ordinary imagination. Because gravity on the moon is only about 1/6 as strong as on Earth, movement becomes slower and lighter. Dust would rise gracefully with each step before falling back in elegant arcs, untouched by wind. The famous footprints left by astronauts remain visible today largely because nothing disturbs them. There's no weather to soften their edges. The impressions wait quietly beneath sunlight, much as they were left decades ago. Perhaps there is something deeply reassuring about a place where even a single footprint can endure for generations. It reminds us that permanence is rare, yet sometimes the universe quietly preserves small moments beyond all expectation. Meanwhile, sunlight continues its slow journey across the lunar landscape. A single day on the moon lasts approximately 29.5 Earth days from one sunrise to the next. Because the moon rotates once during each orbit around Earth, its day unfolds at an extraordinarily patient pace. Imagine standing near the edge of a crater as dawn approaches. The sun would not leap above the horizon within minutes as it does on Earth. Instead, its brilliant edge would rise almost imperceptibly. Hour after hour, shadows would shorten with remarkable slowness. Entire Earth days would pass while the sunlight continued its gradual climb. The mountains surrounding you would cast long black shadows stretching across the dust like ink flowing across paper. These shadows would move so slowly that they might seem frozen, yet over many hours they would quietly shift, revealing details hidden moments before. Temperature follows this slow rhythm as well. Under direct sunlight, parts of the moon can become remarkably hot. During the long lunar night, those same regions grow extraordinarily cold. Without an atmosphere to hold warmth, heat escapes readily into space. Still, even these dramatic temperatures unfold without violence. They are simply the patient consequences of physical laws acting across an airless world. Elsewhere on the surface, countless small craters overlap one another in delicate patterns. Some are enormous enough to contain mountain ranges within their walls. Others are no larger than a family home. Together, they create an intricate texture that tells a story extending across nearly the entire history of the solar system. One impact rarely arrives alone. A larger collision often sends secondary fragments outward, each producing smaller craters upon landing. Over billions of years, these patterns accumulate until the landscape resembles a carefully woven tapestry stitched together through deep time. Seen from orbit, these countless circles blend into gentle shades of gray. Seen from nearby, each crater possesses its own quiet personality. Some have crisp, sharp rims that suggest relative youth. Others have softened edges, worn not by weather, but by endless tiny impacts that slowly reshape every exposed surface. Time, even without wind or water, continues its patient work. Long before human beings learned to measure the age of rocks, the moon had already been keeping careful records. Scientists estimate the ages of different lunar regions by studying crater density. Generally speaking, older surfaces have accumulated more impacts than younger ones. By counting craters of different sizes and comparing these observations with samples returned by astronauts, researchers gradually assembled a remarkable timeline of lunar history. It is an elegant method. Instead of reading pages in a book, scientists read circles in stone. Each crater becomes another quiet sentence written across billions of years. As evening settles over Earth, the same moonlight reaches forests, deserts, mountains, rivers, and cities alike. Owls navigate beneath it. Waves shimmer beneath it. Snowfields glow softly beneath it. Meanwhile, on the moon itself, there is only silence, sunlight, shadow, and the slow accumulation of cosmic dust. The contrast is gentle rather than lonely. Earth is a world of motion. The moon is a world of memory. Together, they have traveled around the sun for billions of years, each offering the other something it cannot provide alone. Slowly, almost unnoticed, our attention drifts toward another remarkable feature hidden within that familiar pale circle above us. The moon does not always show us every side of itself. In fact, nearly everyone who has ever lived has seen essentially the same hemisphere. This familiar face has watched over countless generations. It appeared above ancient campfires, medieval villages, quiet oceans crossed by sailing ships, remote mountain monasteries, and modern cities filled with gentle electric light. The reason is beautifully simple. The moon rotates on its axis at almost exactly the same rate that it orbits Earth. This graceful synchronization is known as tidal locking. Long ago, the young moon likely rotated much faster, but Earth's gravity gently pulled upon it over immense spans of time. Tiny internal deformations within the moon gradually transformed rotational energy into heat, slowing its spin until rotation and orbit settled into perfect harmony. Today, this quiet balance continues without effort. The moon turns, the moon orbits, and almost the same face always looks gently back toward home. There is comfort in rhythms that become so steady they almost disappear from notice. The moon never seems hurried by its endless journey. Perhaps there is something we can borrow from that quiet patience as the night grows deeper and the stars continue their slow and silent watch overhead. Although we always see nearly the same hemisphere, the moon is not entirely motionless from our point of view. Over the course of each month, it performs a subtle and graceful movement known as libration. The word comes from the Latin for balancing, and it describes a gentle rocking that allows us to glimpse slightly beyond the edges of the familiar lunar face. The motion is so delicate that it often escapes casual observation. Night after night, the moon appears almost unchanged, yet careful measurements reveal that it slowly tilts first one way and then another. Sometimes we see a little farther around its eastern edge. At other times, a little more of its western rim comes quietly into view. Similar motions reveal slightly more of the northern and southern regions as well. By combining these gentle shifts, observers on Earth are able to see about 59% of the moon's surface over time, even though no single evening reveals more than one hemisphere. It is a comforting reminder that familiarity often contains quiet surprises. Even something we believe we know completely may reveal a little more of itself when we are patient enough to keep watching. Hidden hemisphere, often called the far side of the moon, remained unknown for nearly all of human history. Every civilization that ever gazed upward saw only the same broad Maria, the same bright highlands, the same arrangement of shadows. The unseen half remained exactly that unseen. For thousands of years, no one knew whether the far side resembled the near side at all. Some imagined similar plains stretching across its surface. Others wondered whether entirely different landscapes might wait there. The answers remained beyond reach, not because they were carefully hidden, but simply because no one yet possessed the means to travel far enough to look. Then, in the middle of the 20th century, humanity quietly crossed an invisible boundary. In 1959, the Soviet spacecraft Luna 3 flew around the moon and photographed the far side for the first time. The images were far from perfect. By modern standards, they appear grainy, soft, and incomplete. Yet they revealed something extraordinary. The hidden hemisphere looked strikingly different. Instead of broad, dark volcanic plains covering large portions of the landscape, the far side was dominated by bright, heavily cratered highlands. There were relatively few Maria compared with the face turned toward Earth. The discovery surprised scientists and opened entirely new questions about lunar history. Why should one side differ so much from the other? Researchers continue to investigate this puzzle, and several explanations have been proposed. Current evidence suggests that differences in crustal thickness played an important role. The far side appears to possess a thicker crust in many regions, making it more difficult for ancient lava flows to reach the surface after giant impacts. On the near side, thinner crust allowed molten rock from deep below to slowly rise and spread across enormous basins, creating the familiar dark plains visible from Earth. The moon, though seemingly symmetrical from afar, carries a subtle imbalance written into its ancient interior. Sometimes The quietest worlds are more varied than they first appear. Imagine standing upon that distant hemisphere. Above you, the sky would remain perfectly black, even during the lunar day. The sun would shine brilliantly, illuminating the gray landscape with sharp, unwavering light. Mountains would cast crisp shadows across fields of ancient stone, but one familiar companion would be missing. Earth would never rise above the horizon. Because the moon is tidally locked, anyone standing on the far side would never see our blue planet hanging overhead. There would be no glowing oceans suspended in darkness, no swirling white clouds, no slowly turning continents. Only the stars, the sun, and the vast silence of space. It is one of the most isolated places accessible within our cosmic neighborhood. Yet isolation, there is not emptiness. The far side possesses its own quiet richness, shaped by impacts, mountains, valleys, and billions of years of undisturbed history. Among its most remarkable features lies the South Pole Aitken Basin, one of the largest known impact structures anywhere in the solar system. Stretching roughly 2,500 kilometers across, this immense basin covers nearly a quarter of the moon's circumference. It is also several kilometers deep, making it an extraordinary window into the moon's ancient interior. Long ago, an object of tremendous size struck the young moon with unimaginable energy. The collision excavated vast amounts of material, exposing rocks that formed deep beneath the original surface. Today, scientists study this region with great interest because samples collected there in the future could reveal valuable information about how the moon, and perhaps even Earth, formed during the earliest chapters of planetary history. Yet, despite its dramatic origin, the basin now rests in complete silence. No echoes remain from that ancient impact. No dust cloud lingers. Only gentle sunlight slowly crossing an immense landscape that has waited billions of years for careful observation. Time has softened even the memory of violence. Meanwhile, another invisible feature quietly surrounds the moon. Unlike Earth, the moon possesses no global magnetic field today. Our own planet generates its protective magnetic shield through the movement of molten iron within its outer core. This invisible field extends far into space, guiding charged particles around much of Earth's atmosphere and producing shimmering auroras near the poles. The moon once possessed a magnetic field of its own, although much weaker and long since vanished. Evidence preserved within ancient lunar rocks suggests that billions of years ago, its interior was more active than it is now. Over immense stretches of time, however, the moon gradually cooled. Its small size allowed heat to escape more quickly than it did from Earth. As the interior became quieter, the global magnetic field faded away. Today, only small patches of magnetized rock remain, preserving faint memories of that earlier chapter. Even invisible histories can leave lasting traces. A compass carried across much of the moon would have little purpose. Instead, ancient minerals quietly remember magnetic directions established billions of years ago, holding delicate clues that modern instruments can still detect. Scientists sometimes describe rocks as storytellers, not because they speak, but because they preserve. Every crystal forms under particular conditions. Every mineral records temperature, pressure, chemistry, and time. Given enough patience, careful observation allows those silent records to become understandable. The moon is filled with such quiet archives. Some are written in lava, others in impact glass, still others within tiny grains, no larger than a grain of sand. Each waits without urgency. Each remains exactly where it has rested for ages, beyond imagination. Elsewhere across the lunar surface, sunlight reflects differently depending upon the texture and composition of the ground. Fresh impact craters often appear brighter because recently exposed material has not yet experienced the slow effects of space weathering. That phrase may sound familiar, although weather on the moon is unlike anything we experience on Earth. There are no clouds, no rain, no wind. Instead, space itself slowly changes exposed rock. Tiny meteorite impacts continually chip away at minerals. Charged particles streaming outward from the sun strike the surface day after day. Over immense spans of time, these processes gradually darken and alter the uppermost layers of lunar soil. Even in perfect silence, change continues. Nothing in the universe remains entirely untouched by time. The freshest craters often display bright rays extending hundreds of kilometers across the surrounding landscape. These graceful streaks consist of material blasted outward during impacts before settling gently back onto the surface. From Earth, some of these ray systems become visible through modest telescopes, spreading across the moon like pale brushstrokes painted in light. One of the most famous examples surrounds Tycho crater. Although Tycho itself is relatively young by lunar standards, about 108 million years old, it still carries brilliant rays that remain visible because insufficient time has passed for space weathering to darken them completely. On geological timescales, even 100 million years can be considered recent. Such comparisons gently reshape our understanding of age. A mountain on Earth may seem unimaginably ancient. A crater on the moon quietly reminds us that the solar system has been keeping time for far longer. As another slow hour passes beneath the stars, our own world continues turning beneath drifting clouds. Night insects sing among grasses. Snow settles across distant peaks. Gentle waves travel toward quiet shores. Far above, the moon continues its patient orbit, carrying with it landscapes where no leaf has ever rustled, where no river has ever curved between hills, and where silence has endured so long that it has become part of the landscape itself. Perhaps that is one reason the moon has always inspired reflection. It offers not an escape from our living world, but a calm contrast to it. Earth teaches us about change. The moon teaches us about endurance. Together, they remind us that the universe makes room for both motion and stillness, for flowing rivers and ancient dust, for growing forests and silent craters, each quietly belonging to the same vast and patient cosmos. As the moon continues its measured journey around the earth, there are places where the sunlight has not reached for extraordinarily long periods of time. Near the lunar poles, the angle of the sun remains forever low above the horizon. Some crater walls are so high, and their interiors so deep, that daylight never quite finds the bottom. These are known as permanently shadowed regions. The phrase carries a quiet elegance. It does not suggest darkness, arriving each evening and departing with the morning. Instead, it describes places where the familiar cycle of day and night has never fully unfolded. For perhaps billions of years, some of these crater floors have remained hidden from direct sunlight. The temperatures within these shadowed depressions are among the coldest measured anywhere in the solar system. Without sunlight to warm the surface, and without an atmosphere to carry heat from nearby illuminated ground, the rocks and dust remain in a state of profound cold, preserving conditions that have changed very little across immense spans of time. Yet, even here, in this patient darkness, scientists have found reason for quiet curiosity. Current evidence suggests that water ice exists within many of these permanently shadowed craters. It does not appear as broad frozen lakes or glittering glaciers like those found on Earth. Instead, tiny grains of ice are thought to be mixed with the ancient soil, hidden beneath layers of dust accumulated over countless ages. The presence of this ice tells a long and gentle story. Some of it may have arrived aboard comets, each carrying frozen water from the distant reaches of the solar system. Some may have been delivered by water-rich asteroids during ancient impacts. Other portions could have formed through subtle interactions between the solar wind and minerals on the lunar surface. Across billions of years, molecule by molecule, these tiny contributions slowly accumulated wherever the sun could not reach. It is remarkable to imagine such delicate preservation. On Earth, ice is constantly changing. It melts into streams, falls again as snow, evaporates into clouds, and returns as rain. Even the oldest glaciers remain part of an active conversation between sky, ocean, and land. The moon keeps a quieter conversation. There, frozen water may wait almost exactly where it settled millions or even billions of years ago, protected by darkness so complete that it has become a kind of natural archive. Perhaps there is comfort in knowing that even the smallest molecules can find places of lasting rest. Elsewhere near the poles, another quiet contrast appears. While some craters never receive sunlight, nearby mountain ridges may remain illuminated for unusually long periods. Because the sun circles low around the horizon rather than rising high overhead, certain elevated regions experience nearly continuous daylight during parts of the lunar year. Scientists sometimes refer to these locations as peaks of near-eternal light. The phrase sounds almost mythical, yet it arises from simple geometry. A mountain standing just high enough above the surrounding terrain can continue catching the sun, while neighboring valleys remain in shadow. The difference between light and darkness may be measured by only a few hundred meters of elevation. One hillside bathes in gentle sunlight, another rests beneath uninterrupted night. These contrasting landscapes have become especially interesting to future exploration. A location with abundant sunlight could provide steady energy through solar panels, while nearby shadowed craters might preserve valuable ice. Together, they form one of the moon's most intriguing partnerships, light and shadow quietly sharing the same horizon. Long before spacecraft confirmed the existence of these regions, observers on Earth could only wonder about conditions near the lunar poles. The moon's slight tilt means that, unlike Earth, its seasons are remarkably subtle. Our planet leans noticeably as it orbits the sun, creating changing patterns of sunlight that bring spring, summer, autumn, and winter. The moon tilts by only about 1.5 degrees relative to its orbit around the sun. As a result, sunlight near the poles always arrives from nearly the same direction. The landscape itself determines where brightness lingers and where darkness quietly persists. Even small differences in height become meaningful across geological time. It is another reminder that immense consequences sometimes arise from remarkably gentle beginnings. Meanwhile, beneath the surface lies a world that no human eye has yet seen directly. The moon is often imagined as a solid sphere of rock, but like Earth, it possesses layers that tell the story of its formation. The outer crust is composed primarily of lighter rocks rich in minerals such as plagioclase feldspar. Beneath this crust lies the mantle, extending hundreds of kilometers downward. Still deeper rests a comparatively small core, made largely of iron and other dense elements. Scientists have learned about these hidden layers through careful measurement rather than direct observation. One of the most valuable methods involves listening. When astronauts from the Apollo missions placed sensitive seismometers upon the lunar surface, they created the first long-term network capable of detecting moonquakes. These instruments quietly waited. Sometimes they recorded vibrations produced by meteorite impacts. Sometimes they detected subtle shifts within the moon itself. Each tiny tremor traveled through different layers before reaching the instruments, allowing researchers to infer the structure hidden far below. In a sense, the moon revealed its interior through echoes. Not echoes carried by air, for there is no atmosphere through which sound can travel across the lunar surface. Instead, these were vibrations moving through solid rock, patiently recorded by instruments resting beneath the silent sky. The moon, though often described as geologically inactive, is not entirely still. Moonquakes occur for several different reasons. Some are caused by the gradual cooling and contraction of the lunar interior. Others result from tidal forces exerted by Earth's gravity, gently flexing the moon as it follows its elliptical orbit. Still, others begin when meteorites strike the surface. Most are quite small, Yet they remind us that even ancient worlds continue changing, however slowly. Nothing in the universe remains perfectly motionless. Even silence contains subtle movement. One particularly interesting characteristic of moonquakes is how long they can continue. Earth seismic waves often fade relatively quickly because our planet's fractured, water-rich interior scatters and absorbs much of their energy. The moon behaves differently. Its dry, rigid rocks allow vibrations to travel efficiently, sometimes continuing for many minutes. Scientists have compared these lingering vibrations to the gentle ringing of a bell. Not because the moon literally sounds like one, but because the motion gradually diminishes rather than ending abruptly. It is a graceful image, a quiet world gently resonating beneath an empty sky. As research continued through the decades, these subtle signals helped reveal details impossible to obtain by observation alone. Knowledge often arrives this way, not through dramatic discoveries, but through careful listening. Far above those hidden layers, another slow process quietly shapes the surface. Every day, the moon is struck by tiny particles arriving from space. Most are microscopic. Some are only slightly larger. Individually, they seem insignificant, but together they perform steady work across unimaginable spans of time. Each impact melts or fractures a minute portion of rock. Minerals shatter. Glassy droplets form. Dust gradually becomes finer. The landscape is continually renewed, not by rivers or volcanoes, but by the endless arrival of material drifting through the solar system. If one could remain there for centuries, the changes would still seem almost invisible. A single human lifetime would scarcely notice them. Yet over millions of years, these tiny encounters become architects of the landscape. Patience is one of nature's most reliable tools. On Earth, we often witness change through weather. Clouds gather, rain falls, leaves emerge, and then quietly drift to the ground. The moon follows another rhythm entirely. Its sculptors are sunlight, cosmic radiation, gravity, and time. There is something deeply calming about recognizing that every world develops according to its own quiet rules. No two planets need resemble one another to belong to the same universe. No two landscapes need share the same history to inspire the same sense of wonder. As our thoughts continue their slow orbit around the moon, it becomes easier to appreciate that this familiar companion is neither lifeless nor empty in the ordinary sense. It is active on timescales so patient that they almost disappear beneath human experience. Its dust is moving. Its rocks are changing. Its interior occasionally trembles. Its orbit slowly evolves. Its ancient craters continue collecting the smallest visitors from space. Everything happens gently. Everything happens without haste. And perhaps that is why the moon feels so well suited to quiet contemplation. It reminds us that not all meaningful change announces itself. Some of the deepest transformations unfold so gradually that they become visible only when viewed across immense stretches of time. Like the moon itself, they simply continue, one patient moment after another, beneath the silent stars. Much of human history, the moon was known only by its light. It rose above quiet fields and sleeping villages, above forests where the leaves barely stirred, and above oceans that reflected its pale glow in long silver paths. Its surface remained beyond reach, close enough to inspire imagination, yet distant enough that every mountain and shadow belonged to mystery. Even after the invention of the telescope, that feeling changed only gradually. The earliest telescopes revealed something unexpected. Rather than a perfectly smooth sphere, as many philosophers had imagined, the moon possessed mountains, valleys, and circular depressions, casting long shadows across its face. As sunlight crept slowly over the lunar landscape, these shadows lengthened and shortened, allowing careful observers to estimate the heights of peaks and the depths of craters. The moon became, little by little, a place rather than simply a light. Among the first to describe these observations in detail was Galileo Galilei in the early 17th century. Looking through a telescope far simpler than even modest instruments available today, he recognized that the changing patterns of light could only be explained by an uneven surface. It was a quiet revolution. The heavens, once imagined as perfectly smooth and unchanging, revealed themselves to possess landscapes every bit as varied as those on Earth. The discovery did not diminish the moon's beauty. Instead, it brought it gently closer. Knowing that mountains stood there, unseen except through careful observation, somehow made the distant world feel more familiar. Over the centuries that followed, astronomers devoted remarkable patience to mapping the lunar surface. Night after night, they returned to the same familiar face. They sketched crater rims. They measured shadow lengths. They compared observations made under different phases. Since low sunlight near the lunar dawn and dusk reveals details that disappear beneath the brighter illumination of lunar midday. Entire careers unfolded beneath this slow rhythm of observation. There was no urgency. The moon would return again next month, and the month after that, and for countless months beyond. Patience became one of astronomy's greatest companions. Long before cameras became commonplace, every map depended upon careful hands. An observer might spend hours looking through an eyepiece, transferring delicate outlines onto paper while trying to remain perfectly steady. Small errors could be corrected on later evenings. New details might appear when sunlight struck from another angle. Gradually, the maps grew richer. Each generation inherited the work of those before it, adding new precision without erasing earlier efforts. Science often advances this way, not through replacing the past entirely, but through quietly refining what careful people have already begun. Eventually, photography joined the story. The first lunar photographs required long exposures and remarkable persistence. Compared with modern images, they appear soft and indistinct, their details blurred by the limitations of early technology. Yet they carried a profound significance. For the first time, Light reflected from the moon could preserve its own likeness without relying entirely upon human drawing. Each photograph became a small conversation between sunlight and chemistry. The moon painted itself. As decades passed, telescopes improved steadily. Lenses became clearer. Mirrors grew larger. Mountaintops offered calmer air for observatories, reducing the shimmering effects of Earth's atmosphere. Astronomers patiently waited for nights when the air itself became especially still. Such moments are known as good seeing. On those quiet evenings, the image within the telescope settles almost imperceptibly. Fine details emerge from gentle steadiness rather than greater magnification alone. It is a subtle lesson. Sometimes clarity depends less upon looking harder than upon waiting for stillness. The same idea quietly echoes beyond astronomy. In calm moments, many things become easier to understand. Meanwhile, the names spread across lunar maps tell stories of curiosity reaching across cultures and centuries. Many craters honor scientists, mathematicians, philosophers, and explorers whose ideas expanded humanity's understanding of the universe. Copernicus, Kepler, Tycho, Archimedes, Plato. Each name marks not ownership, but remembrance. Together they form a landscape where human thought quietly meets ancient stone. The broad volcanic plains received another tradition of naming. Early astronomers, believing these smooth regions might contain water, called them maria, the Latin word for seas. Although later discoveries revealed that they are plains of cooled lava rather than oceans, the names remain. Mare Tranquillitatis, the Sea of Tranquility. Mare Serenitatis, the Sea of Serenity. Mare Imbrium, the Sea of Rains. Mare Crisium, the Sea of Crises. The names carry gentle poetry born from misunderstanding, yet they have become part of scientific history in their own right. Sometimes knowledge preserves traces of the paths by which it arrived. Even mistaken ideas can leave behind beautiful language. The Sea of Tranquility became especially familiar in the summer of 1969. When Apollo 11 descended toward the lunar surface, its landing site lay within this ancient basalt plain, chosen after years of careful study. From orbit, the region appeared relatively smooth compared with many surrounding landscapes. It offered a safer place for humanity's first attempt to land people on another world. Seen from Earth through a small telescope, Mare Tranquillitatis remains simply another dark patch among many. Yet within that quiet plain rests one of history's most remarkable destinations. The surface itself is unassuming. Gray dust, scattered rocks, gentle undulations. Nothing about the landscape announces its importance. Perhaps that is fitting. Nature rarely decorates the places where history quietly unfolds. The first astronauts described a world unlike anything experienced on Earth. Without an atmosphere, the horizon appeared surprisingly close because of the moon's smaller size. The sky remained perfectly black even while the sun shone intensely overhead. Shadows possessed remarkable sharpness, with almost no gradual fading at their edges. The light itself seemed unusually clear. Nothing softened it. Nothing scattered it through air. Every illuminated surface stood in striking contrast to neighboring darkness. Yet, despite these unfamiliar conditions, many descriptions carried an unexpected calm. The landscape appeared ancient, still, almost timeless. There was no movement beyond the astronauts themselves. No drifting clouds, no waving grass, no distant birds, no flowing water. Only the occasional gentle fall of dust disturbed the quiet. Imagine standing there after the spacecraft has departed. The footprints remain. The scientific instruments continue their patient work. The surrounding plain stretches outward beneath brilliant sunlight. Above the horizon hangs Earth, blue and white, slowly turning against the darkness. Cloud systems drift across continents. Storms gather above distant oceans. Night gradually advances across one hemisphere while morning reaches another. From the moon, our planet would appear alive in ways that the lunar landscape does not. The contrast is profound without being sorrowful. One world breathes through weather and water. The other remembers through stone. Both possess their own quiet beauty. Among the objects left behind during the Apollo missions were seismometers, laser reflectors, scientific experiments, flags, tools, cameras, and even small personal mementos. These remain where they were placed, resting beneath the airless sky. The laser reflectors continue serving science today. Powerful observatories on Earth send brief pulses of laser light toward these precisely engineered mirrors. A tiny fraction of that light returns, allowing scientists to measure the Earth-Moon distance with extraordinary accuracy. Each measurement takes advantage of a simple truth. Light travels at a known speed. By timing its journey to the moon and back, researchers can determine the changing distance with astonishing precision. These observations have revealed that the moon is slowly moving away from Earth at a rate of about 3.8 centimeters each year. The change is gentle. Over a single lifetime, it amounts to only a few meters. Yet over hundreds of millions of years, it becomes significant. The reason lies in tides. Earth's rotating oceans create subtle gravitational interactions that gradually transfer a small amount of rotational energy to the moon's orbit. As a result, our planet's rotation slows ever so slightly, while the moon drifts outward into a wider orbit. No one watching the moon tonight could perceive this motion. It unfolds far too slowly, but it is happening all the same. Even the most familiar relationships in the cosmos continue evolving with quiet patience. Perhaps there is comfort in that thought. Change need not be hurried to be real. Some transformations are measured not in days or years, but in geological ages, unfolding so gently that they become part of the background rhythm of the universe itself. The moon has always invited this kind of perspective. It asks very little of us, except that we look upward now and then, allowing our thoughts to wander across its silent plains, its forgotten mountains, and its ancient craters, where time itself seems to move with extraordinary grace. And as the night grows deeper, it becomes easier to imagine that somewhere above the quiet turning of our own world, the moon continues its patient journey, carrying the memories of billions of years beneath the same unchanging stars. As the decades passed after the first footsteps on the moon, the excitement that had once surrounded lunar exploration gradually softened into something quieter. The world continued changing. New technologies emerged. Satellites became common companions above the Earth, and attention often turned toward other destinations across the solar system. Yet the moon never truly left humanity's thoughts. Instead, it waited with its familiar patience. The footprints remained where they had been placed. The experiments continued their silent observations for as long as their power allowed. Dust slowly settled around objects that would not be disturbed by wind, rain, or growing plants. Time continued its careful work without erasing the evidence of those brief visits. There is something deeply peaceful about imagining those landing sites today. The descent stages of the lunar modules still rest upon the surface. Nearby lie scientific instruments, gentle tracks left by astronauts, and pathways crossing the fine gray soil before fading into the distance. Nothing has hurried them away. On Earth, abandoned places are quickly reclaimed. Grass grows through cracks in stone. Trees slowly surround forgotten buildings. Rain softens sharp edges. Snow comes and goes with each passing winter. The moon follows another rhythm. There, abandonment is not decay in quite the same sense. It is simply stillness. For many years after the Apollo missions, robotic spacecraft became the quiet caretakers of lunar exploration. Unlike human visitors, they required no air to breathe, no food to carry, and no return journey at the end of their work. They could patiently orbit, photograph, measure, and transmit information home for months or even years. Each mission added another small piece to a steadily growing understanding. Rather than replacing earlier discoveries, they gently expanded them. High-resolution cameras revealed details far smaller than those visible from previous spacecraft. Laser altimeters measured elevations with remarkable precision, slowly constructing three-dimensional maps of mountains, valleys, and crater rims. Spectrometers examined the chemistry of surface minerals by studying the light reflected from them. Radar instruments looked beneath loose surface layers, offering hints about structures hidden below. Each instrument contributed its own quiet perspective. No single measurement told the entire story. Together, however, they formed a picture of increasing richness. Science often resembles assembling a mosaic. One small stone alone appears insignificant. Thousands arranged patiently reveal an image that no single piece could contain. Among these later explorers was the Lunar Reconnaissance Orbiter, launched in 2009. For many years, it has circled the moon with remarkable consistency, photographing nearly every region in extraordinary detail. Its images reveal landscapes so crisp that individual boulders become visible. Old landing sites can be identified. Astronaut trails appear as faint lines crossing the dust. Even shadows cast by scientific equipment can sometimes be distinguished under favorable lighting. The photographs possess a quiet intimacy. From hundreds of kilometers above the surface, they allow us to see places once visited by only a handful of people. The footprints themselves remain too small to resolve directly, yet their pathways can still be traced through the subtle disturbances they created in the lunar soil. It is a gentle reminder that history sometimes leaves marks far more delicate than monuments. Meanwhile, orbiting spacecraft have continued revealing surprising details about the moon's chemistry. One particularly important discovery involved hydroxyl molecules and water-related compounds spread across portions of the lunar surface. For many years, scientists assumed the moon was almost entirely dry. That assumption has gradually become more nuanced. Current evidence suggests that small amounts of water-related molecules may form through interactions between the solar wind and oxygen contained within lunar minerals. Hydrogen nuclei carried outward from the sun occasionally become embedded within surface materials. There they can combine with oxygen atoms already present inside the rocks, producing hydroxyl, and under some conditions, water molecules. These processes remain an active area of research. Scientists continue investigating exactly how these molecules form, migrate, and accumulate. The moon, once thought to be almost completely devoid of water, has quietly revealed itself to be more complex than first imagined. Nature often rewards patience with deeper understanding. What seems simple from a distance may contain remarkable subtlety upon closer examination. As our thoughts wander across the lunar surface, another gentle process unfolds almost invisibly. Every sunrise and sunset on the moon places stress upon the rocks. During the long lunar day, sunlight warms exposed surfaces. During the equally long night, temperatures fall dramatically. Although there is no atmosphere to produce frost or flowing water, these repeated cycles of heating and cooling slowly weaken exposed stone. Tiny cracks develop. Minerals expand and contract at slightly different rates. Over immense periods of time, larger rocks gradually fracture into smaller pieces. Eventually, they become part of the fine regolith covering much of the moon. It is a remarkably quiet form of weathering. No thunder accompanies it. No rushing river carries fragments away. The rocks simply respond, year after year, to changing temperatures beneath an airless sky. Even silence possesses its own patient ways of reshaping the world. Some lunar boulders cast shadows that have remained almost unchanged for countless generations. When sunlight first reaches them after the long night, the surrounding landscape brightens gradually. The darkness retreats with extraordinary slowness. Hours pass, then days. Only after many Earth days does the sun climb high enough for shadows to become noticeably shorter. One could imagine sitting safely nearby, watching this gradual transformation unfold. The experience would require unusual patience. Yet, perhaps, it would also reveal something often overlooked in everyday life. Not every beautiful change happens quickly. Many of the most meaningful rhythms in nature unfold almost too slowly for ordinary attention. Elsewhere across the moon, ancient lava tubes may rest beneath the surface. These remarkable structures likely formed billions of years ago during periods of volcanic activity. When rivers of molten rock flowed across the landscape, their outer surfaces sometimes cooled first, forming solid roofs above still-moving lava. As the molten interior eventually drained away, long hollow tunnels remained. On Earth, similar lava tubes can be found in volcanic regions such as Iceland, Hawaii, and the Canary Islands. The lunar versions may be considerably larger. Because gravity on the moon is much weaker, the ceilings of these underground passages could span impressive distances without collapsing. Scientists continue studying whether such lava tubes might one day provide natural shelter for future explorers. Protected beneath layers of rock, they would offer shielding from radiation, extreme temperature changes, and the constant arrival of tiny meteorites. For now, however, they remain largely unexplored. Quiet chambers waiting beneath ancient plains. The idea carries a certain peaceful mystery, not mystery born from fear. Rather, the gentle mystery of knowing that even our nearest celestial neighbor still contains places no human has entered. The universe does not require every question to be answered immediately. Sometimes it allows curiosity to mature slowly across generations. Long before anyone imagined underground lunar caverns, countless meteorites had already been delivering tiny gifts to the surface. Many people picture meteorites only as dramatic fireballs crossing the night sky. Yet much of the material arriving at the moon consists of particles scarcely larger than grains of dust. Without an atmosphere to burn them away, even these minute travelers complete their journeys. Every day, they settle upon the moon in astonishing numbers. Individually, they change almost nothing. Collectively, they slowly renew the uppermost layer of regolith. It is another example of quiet accumulation. The smallest contributions, repeated often enough across immense stretches of time, become significant. Nature rarely hurries. Instead, it patiently adds one moment to the next. As our own planet turns beneath drifting clouds tonight, countless tiny particles continue falling toward the moon. Some have traveled for millions of years through interplanetary space. Others began their journeys after ancient collisions between asteroids. Each arrives without announcement. Each becomes another nearly invisible thread woven into the long history of the lunar surface. Perhaps there is comfort in imagining such gentle continuity. While human generations come and go, while cities grow and rivers change course, the moon continues receiving these quiet visitors from space, just as it has for billions of years. The process is almost beyond noticing. Yet, it never truly stops. Far above the moon, the stars remain steady. Far below them, ancient craters continue keeping their silent watch. And somewhere within that immense stillness, Every tiny grain of dust becomes part of a story so patient that it can only be understood by looking not at days or years, but at the slow and graceful passage of deep time itself. Beyond the broad volcanic plains and the familiar craters that can be seen through small telescopes, the moon is home to mountain ranges that have stood in quiet silence since long before complex life appeared on Earth. They do not rise because continents collided, as many mountains on our own planet have done. Instead, they owe their existence to ancient impacts that reshaped the lunar crust during the earliest history of the solar system. When an enormous asteroid struck the young moon billions of years ago, the surface responded for a brief moment, almost like the surface of a pond after a stone has fallen into it. Rock that had been compressed beneath unimaginable pressure rebounded upward, while rings of fractured crust rose around the newly formed basin. The violence of those moments has long since disappeared. What remains are mountains that now seem almost impossibly peaceful. The Montes Apenninus, one of the moon's most prominent mountain ranges, stretches for hundreds of kilometers along the edge of the vast Mare Imbrium basin. Some of its peaks rise more than 5 kilometers above the surrounding plains, making them comparable in height to many famous mountains on Earth. Yet their appearance is quite different. Without rivers carving valleys, without forests softening their slopes, and without clouds drifting across their summits, the mountains seem remarkably clear in outline. Every ridge casts a crisp shadow beneath the low sun. Every cliff appears sharply defined against the quiet gray landscape. The airless environment preserves these forms with extraordinary patience. On Earth, a mountain is constantly changing. Rain finds tiny cracks. Ice expands within them during winter. Rivers carry away loose stone grain by grain. Plants slowly anchor themselves wherever soil collects. The mountain becomes part of an ongoing conversation with water, wind, and living things. The moon's mountains speak far less often. They simply remain. If one could stand upon a lunar summit, the horizon would appear noticeably closer than it does on Earth because the moon itself is much smaller. The curve of the surface would become gently apparent across the distance, giving the landscape an intimate sense of scale despite its vast emptiness. Above, the sky would remain perfectly black. No blue would soften the contrast between rock and space. Stars, however, would usually not be visible while the sun illuminated the surface. The bright sunlight reflecting from the ground would overwhelm all but the brightest celestial objects, much as daylight does on Earth, though for different reasons. It is one of those quiet details that often surprises people. An airless sky is not automatically filled with visible stars. Light itself gently shapes what the eye can perceive. Meanwhile, Earth would hang above the horizon for anyone standing on the near side of the moon. Unlike our moon, which rises and sets because of Earth's rotation, Earth would appear almost stationary in the lunar sky. It would drift only slightly back and forth because of the moon's gentle libration. Over many hours, clouds would slowly rearrange themselves. White storms would spiral across blue oceans. The continents would turn from sunlight into darkness and back again. From the moon, one Earth day would pass while our planet completed a graceful rotation beneath its blanket of clouds. Imagine quietly watching that distant globe. The familiar becomes unfamiliar when seen from far away. Mountain ranges disappear into the larger shapes of continents. Cities vanish entirely. Borders become invisible. Only oceans, clouds, deserts, forests, and ice remain. Distance has a gentle way of simplifying what once seemed complicated. Perhaps that is one reason so many astronauts later spoke about seeing Earth as a single shared home. The farther away they traveled, the more quietly unified our world appeared. Long before human beings had that extraordinary perspective, another observer was already studying the moon with remarkable dedication. In the late 19th century, photographers began creating increasingly detailed lunar atlases. Each clear night offered another opportunity. Glass photographic plates carefully captured subtle differences in brightness. Observers compared images taken under different lighting conditions. Features hidden at one phase became visible at another. Slowly, the maps improved. There was no shortcut. The moon encouraged careful repetition. Night after night, month after month, year after year, knowledge accumulated almost imperceptibly, like layers of fine dust settling upon the lunar surface. Even today, professional astronomers often return to the same regions many times. Although the moon appears unchanging, different illumination reveals different textures. A crater that seems ordinary beneath a high sun may become strikingly beautiful when sunrise sends long shadows stretching across its floor. Gentle ridges emerge. Small hills become visible. The landscape gains depth. It is not that the moon has changed. Only the light has. This simple observation carries a quiet lesson beyond astronomy. Sometimes understanding grows, not because the subject itself has altered, but because we have learned to look from another angle. Elsewhere across the moon, winding channels known as sinuous rills trace graceful paths through ancient volcanic terrain. At first glance, they resemble dried river valleys. For many years, some observers even wondered whether flowing water might once have carved them. Modern research suggests a different story. Most sinuous rills were probably formed by flowing lava during the moon's volcanic past. As molten rock moved across the landscape billions of years ago, it gradually eroded or thermally modified its own channels, creating broad curves that still remain visible today. Some rills extend for hundreds of kilometers. They wander across the plains with surprising elegance, reminding us that even on a world without rivers, landscapes can develop graceful forms. The resemblance to river valleys is a beautiful example of nature arriving at similar shapes through different processes. The universe often repeats patterns while writing entirely different stories. Nearby lie wrinkle ridges, long, gentle folds crossing the smooth Maria. These ridges formed after the lava plains cooled. As the thick basalt slowly contracted over immense spans of time, the crust compressed slightly, pushing sections of the surface upward into broad ridges. Unlike mountain ranges created by dramatic collisions, wrinkle ridges rise quietly. Some are only a few hundred meters high, yet they stretch across remarkable distances. Seen from orbit, they resemble soft waves frozen in stone. Their curves remind us that even solid rock can bend when given enough time. Geology often teaches patience. Processes that appear impossible during a human lifetime become entirely natural across millions of years. The moon asks us repeatedly to think in these longer rhythms. Far beneath those ridges, ancient lava rests exactly where it cooled billions of years ago. No underground rivers circulate through it. No tree roots slowly widen fractures. No burrowing animals disturb the layers. The volcanic history remains preserved with unusual clarity. Scientists examining lunar samples have found tiny crystals that formed as molten rock gradually cooled. Each mineral records the conditions present at the time of its formation. Some cooled quickly near the surface. Others crystallized more slowly beneath layers of insulating rock. Together, they reveal details about volcanic eruptions that ended long before complex organisms appeared on Earth. Tiny crystals become quiet historians. They ask only to be examined with care. Among the most fascinating of these minerals are small grains containing isotopes that allow scientists to estimate their ages. Radioactive elements decay at predictable rates, gradually transforming into other elements over immense periods. By measuring the proportions of parent and daughter isotopes within carefully selected samples, researchers can determine when particular rocks solidified. The method is remarkably elegant. The rocks themselves become clocks, not clocks with moving hands or ticking gears, but clocks written into the structure of atoms. Every measurement gently extends our understanding of lunar history. No single sample tells the whole story. Each contributes another calm sentence to a narrative billions of years in the making. As evening deepens across our own world, the moon continues reflecting sunlight that began its journey from the sun a little over 8 minutes before reaching the lunar surface. From there, a small fraction of that light travels onward to Earth, taking just over 1 additional second to arrive. The moonlight falling across quiet rooftops, peaceful lakes, distant mountains, and sleeping forests tonight has already completed a remarkable voyage through space. It has left the sun. It has touched the ancient dust of the moon, and only then has it gently reached our eyes. There is something quietly beautiful about that journey. Even the softest moonlight carries within it the memory of two worlds, one blazing with constant nuclear fire, the other silent beneath billions of years of patient stone. Between them stretches the darkness of space, vast yet orderly, where light travels faithfully onward without hesitation, linking distant places in ways that are almost impossible to notice during an ordinary evening. And perhaps that is one of the moon's greatest gifts. It reminds us that the universe is filled with quiet connections. Some are measured in gravity, some in light, some in time, all of them unfolding with extraordinary patience, inviting us simply to look upward for a little while longer and to rest within the gentle certainty that the cosmos has never been in a hurry. The moon has another quiet habit that has accompanied every generation of human observers. It changes its appearance with dependable grace, moving from a slender crescent to a bright full disk before gradually returning once more to darkness. These familiar phases have become such an ordinary part of life that it is easy to forget how remarkable they truly are. The moon itself does not grow brighter or dimmer, nor does it slowly change shape. Instead, we see different portions of its sunlit hemisphere as it travels around the Earth. It is a simple consequence of geometry, unfolding with such regularity that people have used the lunar cycle to measure time for thousands of years. Imagine watching the moon every evening from the same quiet hillside. At first, only the thinnest crescent hangs above the western horizon after sunset. Its delicate curve seems almost fragile against the deepening blue of twilight. Most of the moon remains invisible, though a faint glow often outlines the darker portion. This gentle illumination is called earthshine. It is one of the most subtle and beautiful sights in the night sky. The light does not come directly from the sun alone. Instead, sunlight first reflects from the earth, then softly illuminates the moon's night side before returning once more across space to our eyes. In a sense, the earth becomes a second moon for the moon. Our oceans, clouds, deserts, forests, and ice sheets scatter sunlight outward into space, bathing the lunar landscape in a pale gray glow. An astronaut standing within the darkness of a young lunar crescent would witness something extraordinary. High overhead, Earth would appear almost completely full. It would shine several times brighter than the full moon appears from Earth, casting a gentle light across the surrounding plains. Cloud systems would slowly drift. Storms would spiral over distant oceans. The great blue planet would illuminate the silent dust with a calm radiance. Even in darkness, neither world is entirely alone. As the days pass, the crescent slowly widens. Night after night, the line separating day from night on the moon shifts gently across the surface. This boundary is known as the terminator. Despite its somewhat dramatic name, the terminator is simply the moving frontier between sunlight and shadow. It is one of the most rewarding regions for careful observation. Near the terminator, the sun sits low above the lunar horizon. Mountains cast long shadows. Crater walls become strikingly three-dimensional. Small hills emerge from darkness, while neighboring valleys remain hidden. Features that appear almost flat beneath the full moon suddenly reveal remarkable depth. Professional astronomers and amateur observers alike often prefer studying the moon during these phases. The softer lighting uncovers delicate textures that bright overhead sunlight tends to conceal. It is much like walking through a landscape during the first light of morning, or the quiet hours before sunset. Low sunlight reveals gentle details. Long shadows give familiar places renewed character. Light becomes an artist, patiently shaping our perception. There is something comforting about this rhythm. Nothing on the moon itself has changed, only the angle of the sunlight. Yet the experience becomes entirely different. Perhaps understanding often grows in the same way. Sometimes all that changes is the light from which we choose to observe. Gradually, the moon reaches its first quarter phase. Despite the name, we see half of its visible face illuminated. The phrase first quarter refers not to how much of the moon appears bright, but to its position, 1/4 of the way through its orbit around Earth. This is one of those gentle reminders that scientific language often carries histories of its own. Words preserve older ways of describing the world, quietly accompanying modern understanding. As another week passes, the moon becomes gibbous. Its bright surface now appears almost complete. Only a narrow strip near one edge remains in darkness. The familiar Maria stand out clearly. The sea of tranquility, the sea of serenity, the ocean of storms, ancient lava plains gently reflecting sunlight that left the sun only moments before. Each evening, the moon rises a little later than it did the night before. On average, moonrise shifts by about 50 minutes each day, though the exact interval varies because of the moon's changing orbit and the observer's location on Earth. This slow delay is another quiet consequence of celestial motion. While Earth rotates once each day, the moon continues moving eastward along its orbit. Our planet must therefore rotate a little farther before the moon once again appears above the horizon. The heavens possess remarkable consistency. Every apparent delay carries an elegant explanation. Eventually, the full moon arrives. Its familiar brightness transforms the night. Fields become softly illuminated. Snow glows with remarkable clarity. Clouds acquire silver edges. Gentle waves shimmer beneath moonlight. Many nocturnal animals quietly adjust their behavior during these brighter nights. Some hunt more cautiously. Others seek additional shelter. Certain species time important activities according to the changing phases of the moon. Even coral reefs, thousands of kilometers away beneath warm tropical seas, often coordinate spawning events with particular lunar cycles. The moon's influence reaches into places where its light itself never enters. Its gravity quietly shapes the tides. Its changing brightness gently influences countless living creatures. Without making any sound, it participates in the rhythms of life on Earth. Yet, the full moon also presents an interesting challenge for astronomers. Because sunlight falls almost directly upon the visible surface, shadows become extremely short. Many craters that appear dramatic near the terminator become surprisingly difficult to distinguish. The landscape seems flatter. Subtle ridges nearly disappear. Brightness overwhelms texture. It is another reminder that more light does not always reveal more detail. Sometimes gentler illumination allows deeper understanding. After the fullness has passed, the moon begins its gradual return. Night by night, darkness quietly advances across the opposite side. The waning gibbous becomes the last quarter. The last quarter slowly becomes a fading crescent. Morning observers see it rising before dawn, hanging peacefully above sleeping towns and quiet rivers, while the eastern horizon begins to brighten. There is a special stillness in those final crescent mornings. The world often feels suspended between night and day. Birdsong has only just begun. Mist rests above lakes and meadows. The stars slowly surrender to the approaching sun. And there, above it all, the old moon quietly prepares to complete another orbit. For countless generations, people have noticed these dependable cycles. Farmers planned their work. Sailors watched the tides. Poets found quiet inspiration. Scientists measured careful observations. Children simply looked upward with curiosity. The moon welcomed them all equally. It asked for no special knowledge before revealing its beauty. Perhaps that is one reason it has remained such a faithful companion throughout human history. It belongs to everyone who pauses long enough to notice it. As our thoughts continue drifting across its familiar face, another quiet truth emerges. The moon has never repeated a single night exactly. Its phases return, its orbit continues, yet clouds differ, seasons change, observers grow older. New generations lift their eyes toward the same pale companion. The moon remains familiar without ever becoming entirely the same. There is comfort in that balance, a rhythm steady enough to trust, a world ancient enough to endure, a light gentle enough to accompany both celebration and solitude, carrying its calm presence across oceans, mountains, forests, deserts, and sleeping cities, just as it has done for uncounted thousands of years. And somewhere, beyond all those quiet landscapes, the moon continues its patient journey, never hurrying toward tomorrow, never lingering in yesterday, simply following the graceful path that gravity traced for it long before any human being learned to look up and wonder. Long before the first spacecraft crossed the quiet distance between Earth and the moon, people wondered what the lunar surface might truly be like. The imagination filled the unknown with possibilities. Some pictured smooth plains where a traveler could walk for hundreds of kilometers without encountering an obstacle. Others imagined towering mountains rising beyond anything found on Earth. There were even careful debates about whether a spacecraft might disappear into a deep layer of dust upon landing. The uncertainty was understandable. From nearly 400,000 kilometers away, even the finest telescopes could reveal only so much. Light traveled faithfully across the distance, but the smallest details remained hidden, softened by the Earth's atmosphere and by the limits of the instruments themselves. The moon waited quietly for closer visitors. In the late 1950s and early 1960s, a series of robotic missions began that careful approach. Their purpose was not only to reach the moon, but to understand it well enough that future explorers might arrive safely. Each mission answered a few questions. Each also uncovered new ones. The process unfolded with remarkable patience, much like astronomy itself. Among the earliest spacecraft were the Soviet lunar missions. Several attempts ended unsuccessfully, as was often the case during those pioneering years. Space exploration was still very young, and every journey beyond Earth's atmosphere required engineers to solve problems that no one had ever encountered before. Yet each attempt, successful or not, quietly contributed to future progress. Knowledge accumulated through careful refinement. Mistakes became lessons. Lessons became confidence. Eventually, in 1959, Luna 2 became the first human-made object to reach the moon, arriving not through a gentle landing, but by impacting the surface. Its journey lasted only a few days. Its mission ended in a brief collision, yet its significance endured. For the first time, something built by human hands had completed the journey to another celestial body. The moon, which had inspired stories for countless generations, had become a destination rather than only a distant companion. Not long afterward came Luna 3, carrying a camera that would forever change humanity's understanding of the moon. As it passed around the far side, hidden from direct communication with Earth for part of its journey, the spacecraft photographed landscapes that no person had ever seen. The images were transmitted slowly back across space, line by line, signal by signal. Though modest by modern standards, they carried extraordinary meaning. The unseen hemisphere was no longer unknown. There is something quietly moving about those first photographs. Today, we are accustomed to detailed images, arriving almost instantly from distant spacecraft. Yet those early pictures represented months and years of planning, followed by a patient wait while faint radio signals crossed the vast distance home. Every image was treasured. Every new crater became familiar. Meanwhile, engineers on Earth continued refining another essential skill. Reaching the moon was only part of the challenge. Landing gently required an entirely different kind of precision. Without an atmosphere, parachutes would be useless. A spacecraft would need to control its descent using carefully timed rocket engines, slowing from thousands of kilometers per hour until it touched the surface almost delicately. It was a remarkable engineering problem, not because the moon resisted. The moon simply followed the same physical laws it always had. The challenge lay in learning to work with those laws rather than against them. Beginning in the mid-1960s, the Surveyor missions demonstrated that gentle landings were indeed possible. These robotic spacecraft descended slowly toward carefully selected regions, using radar to judge their altitude and engines to reduce their speed. One by one, several Surveyor landers settled safely onto the lunar surface. Their cameras looked outward across quiet plains of dust and scattered rocks. For the first time, humanity could see the moon not merely from orbit, but from ground level. The photographs possess an unusual serenity. The horizon sits close beneath the black sky. Small stones rest exactly where they have lain for millions of years. Shadows stretch sharply across fine gray soil, Nothing moves, nothing rustles, nothing interrupts the profound stillness. The surveyor missions answered an important practical question as well. The lunar surface was firm enough to support a spacecraft. The feared oceans of deep, unstable dust did not exist. Instead, the landers rested securely upon compact regolith formed through billions of years of tiny impacts. Sometimes the most reassuring discoveries are the simplest ones. The ground was solid. That quiet fact opened the door to everything that followed. Elsewhere above the moon, another series of spacecraft quietly prepared the way. The lunar orbiter missions photographed potential landing sites from space with remarkable detail for their time. Engineers searched for regions that balanced scientific interest with relative safety. Too many large boulders could threaten a landing. Steep slopes posed unnecessary risk. Deep craters required careful avoidance. The selected sites reflected countless hours of thoughtful analysis. Each image was examined carefully. No decision was rushed. The moon itself had waited billions of years. Another few months of careful planning made little difference to such an ancient world. As these preparations continued, scientists learned more about the moon's gravity. Although often imagined as perfectly uniform, the lunar gravitational field contains subtle variations. Some regions exert a slightly stronger gravitational pull than others. These differences arise from variations in the density of rocks beneath the surface. Large impact basins filled with dense volcanic basalt contribute to some of these gravitational anomalies. They are known as mascons, short for mass concentrations. At first, these hidden regions puzzled researchers. Spacecraft orbiting the moon behaved ever so slightly differently than expected. Tiny changes in their paths revealed that something beneath the surface was quietly influencing their motion. Gravity itself became a messenger. Without seeing the buried structures directly, scientists learned about them by carefully observing how spacecraft moved overhead. It is a wonderfully gentle example of how science often works. Invisible things reveal themselves through their effects. The moon does not need to announce its secrets. It simply follows the laws of nature with perfect consistency. Patient observers gradually learn to listen. The discovery of mascons improved future navigation around the moon. Spacecraft trajectories became more accurate. Orbital predictions grew increasingly reliable. Another small uncertainty quietly disappeared. Knowledge, once gained, became part of every mission that followed. Meanwhile, the moon continued exactly as before. Its mountains cast long shadows. Its craters gathered tiny particles from space. Its orbit carried it faithfully around the Earth. Whether watched by ancient shepherds or modern spacecraft, it remained the same patient companion. Perhaps that is one of the most comforting qualities of the moon. Human understanding changes. Technology advances. Questions become answers, and answers inspire new questions. Yet the moon itself does not hurry through these transformations. It simply waits. Every generation is invited to learn a little more than the one before. Every careful observation adds another quiet page to a story that began billions of years ago and continues beneath the same silent sky tonight. And as our own thoughts drift gently onward, following the path of those early robotic explorers, it becomes easier to appreciate that discovery is rarely a single dramatic moment. More often, it is a long conversation between curiosity and patience, carried forward one careful step, one clear image, and one quiet observation at a time. By the time the first astronauts prepared to travel toward the moon, thousands of people had already devoted years of careful thought to a journey that would last only a handful of days. Engineers refined engines until they performed with quiet reliability. Mathematicians calculated trajectories that would carry a spacecraft across nearly 400,000 kilometers of open space. Scientists studied lunar maps, comparing one potential landing site with another, always searching for places that were both scientifically interesting and gently welcoming. The voyage itself would not be hurried. Although rockets leave the Earth with tremendous power, much of the journey to the moon is surprisingly peaceful. After the powerful launch, after the bright flame fades into the distance, and the final stage of the rocket completes its work, the spacecraft simply continues along its path, carried forward by the momentum it has already gained. Inside, the astronauts enter a quieter rhythm. Windows reveal the slowly shrinking Earth. The moon, still distant, grows almost imperceptibly larger with each passing hour. Between the two worlds stretches an immense silence. Space is often imagined as a place of constant activity, yet for travelers crossing the distance to the moon, there are long periods where very little appears to change. The stars remain steady. The spacecraft drifts gently through darkness. Small course corrections are made when necessary, each one carefully measured and almost delicate compared with the tremendous energy of launch. There is time to observe, time to think, time simply to watch the Earth slowly rotate beneath its changing clouds. Perhaps this quiet cruise is one of the least appreciated parts of lunar exploration. The destination captures most of our attention, yet the journey itself unfolds with remarkable calm. It is less like racing across an ocean and more like patiently following a current that has already been chosen. As the spacecraft approaches the moon, its gravity gradually becomes the dominant influence. The invisible balance between two worlds shifts ever so gently. A carefully timed engine burn allows the spacecraft to slow just enough to be captured into lunar orbit. Without that adjustment, it would simply continue past the moon and onward through space. Precision matters. But once again, the moon itself offers no surprises. Gravity behaves exactly as it always has. The challenge lies only in understanding it well. From orbit, the lunar surface reveals a kind of beauty that differs from almost every landscape on Earth. Entire crater chains become visible. Mountain ranges trace graceful arcs around enormous impact basins. Dark maria spread across the surface like calm inland seas, remembered only by name. The horizon curves gently away in every direction, reminding the observer that this ancient landscape belongs to a world complete unto itself. There are no national borders, no roads, no cities, only geology written across deep time. One orbit follows another, each lasting about 2 hours. With every circuit, sunlight falls from a slightly different angle. Shadows drift slowly across crater walls. Bright peaks emerge from darkness, while neighboring valleys quietly disappear into it. The moon seems less like a collection of separate landmarks and more like a single, connected story told across stone. Among the most memorable sights from lunar orbit is Earth itself. Seen rising above the horizon of the moon, our planet appears luminous and alive. The famous image, often called Earthrise, captured this perspective during the Apollo 8 mission. Although people sometimes imagine Earth rising repeatedly as the moon turns, the experience depends upon the spacecraft's motion in orbit. For someone standing on the lunar surface, Earth would remain nearly fixed in the sky. But from an orbiting spacecraft, the changing viewpoint allows that unforgettable moment when the blue globe slowly emerges beyond the gray horizon. The photograph has become one of the most recognizable images ever made. Yet its power lies in its simplicity. No dramatic event is taking place. No explosion. No sudden discovery. Only one world quietly appearing above another. Sometimes the gentlest images become the most enduring. Looking back toward Earth from lunar orbit offers a perspective that quietly changes familiar ideas. The oceans dominate. Clouds drift across nearly every continent. The atmosphere forms an astonishingly thin blue line surrounding the planet. From such a distance, it becomes easier to appreciate how delicate that atmosphere truly is. Almost every weather pattern, every forest, every ocean wave, every conversation, every song, every sleeping village and bustling city exists beneath that remarkably slender layer of air. The moon, by comparison, wears no such veil. Its horizon meets the darkness of space directly. There is no twilight, no glowing sunset lingering after the sun has disappeared. Day ends suddenly. Night begins without ceremony. The contrast between the two worlds feels gentle rather than dramatic. Earth wraps itself in air. The moon rests beneath open space. Both simply follow the paths that nature has given them. As preparations for landing continue, the spacecraft separates into 2 parts. One remains in orbit, while the lunar module begins its slow descent. This remarkable vehicle was designed for a single purpose. It would never travel through Earth's atmosphere. It needed no smooth aerodynamic shape. Instead, it resembled something almost sculptural. All legs, panels, antennas, and carefully placed engines. Every feature reflected function rather than appearance. Beauty emerged from purpose. The descent begins gradually. At first, the module moves almost sideways relative to the surface, reducing its orbital speed while allowing gravity to pull it gently downward. The engines provide steady control. Radar measures altitude. Computers calculate guidance continuously. The astronauts monitor every stage with quiet concentration. Although history often remembers these moments for their significance, much of the experience consisted of careful observation and calm decision-making. The moon did not demand haste. It required precision. Outside the windows, craters pass slowly beneath. Shadows reveal subtle slopes. Individual boulders become visible. The surface that once appeared smooth through telescopes now displays countless delicate textures. Dust-covered hills, scattered rocks, gentle undulations shaped by impacts long forgotten. Closer still, the engine continues its patient work. Its exhaust begins disturbing the fine regolith below. Unlike dust on Earth, lunar dust is not lifted by moving air. Instead, individual particles are pushed directly outward by the engine plume, following graceful arcs before settling back upon the ground. For a few moments, the surface becomes softly veiled by drifting gray grains. Then the descent ends. The landing legs touch the ancient plane. Motion ceases. After nearly 400,000 kilometers of travel, the spacecraft rests quietly upon a world that has waited more than 4 billion years for this meeting. Outside, nothing has changed. The mountains remain silent. The craters remain still. Sunlight continues falling across the landscape exactly as it had moments before. The arrival of human visitors does not disturb the moon's calm nature. It simply adds another small chapter to an already ancient story. There is something deeply reassuring about that. The universe welcomes discovery without needing to transform itself for our sake. We arrive, we observe, we learn. The stars continue shining. The moon continues orbiting. Time continues flowing with the same patient rhythm. Perhaps that is why lunar exploration feels so enduring. It reminds us that even our greatest achievements become part of something much larger than ourselves, not diminished by that perspective, rather gently embraced by it. As the first footsteps prepare to press into the quiet dust, the landscape waits exactly as it has through countless ages, still, ancient, and entirely unhurried, beneath a sky where no wind has ever blown, and where silence has become as much a part of the moon as the stone itself. The first human footsteps on the moon were placed upon a surface that had not felt the touch of life from Earth for billions of years. The dust beneath the astronauts' boots had formed through endless collisions with tiny particles from space, through ancient volcanic eruptions, and through the slow breaking apart of rocks beneath changing temperatures. It was a landscape shaped by time alone. When the first astronaut stepped down from the lunar module, the moment carried enormous meaning for people watching from Earth. Yet from the moon's perspective, everything remained wonderfully quiet. The sun continued shining. The stars remained distant. The ancient craters continued holding their shadows. The mountains continued standing where they had stood for ages, beyond human memory. A single footprint appeared, and then another. A small disturbance upon a vast and ancient world. There is something deeply moving about the scale of that contrast. A human being, carrying the history of Earth within a spacesuit, standing upon a landscape that existed long before any human thought had formed. Two different stories meeting briefly. One measured in decades, the other measured in billions of years. The lunar surface offered a strange combination of familiarity and unfamiliarity. The astronauts recognized rocks, dust, mountains, and horizons. Yet every familiar feature existed within an environment unlike anything found on Earth. The absence of atmosphere changed everything. Without air, there was no scattering of sunlight to create a blue sky. There was no distant haze softening the horizon. Objects far away appeared remarkably sharp. A mountain several kilometers distant did not fade into atmospheric mist. It simply stood against the darkness of space. The astronauts described the landscape as both beautiful and difficult to judge. Without familiar references such as trees, buildings, or clouds, distances became deceptive. A crater that appeared nearby could be several kilometers away. A hill that looked small could rise hundreds of meters. The moon required a new way of seeing. The human eye had evolved beneath Earth's atmosphere. Here, it needed to learn another world. Walking itself became a gentle experiment. Because gravity on the moon is much weaker than on Earth, every movement felt different. The astronauts discovered that a hopping motion often worked better than ordinary walking. Their bodies rose higher with each step. Their movements appeared almost slow and graceful. The famous footage of lunar walking has a dreamlike quality, as if the explorers were moving through a place halfway between Earth and the stars. This was not because they were floating. The moon still held them firmly. Gravity remained present. It was simply reduced. A person who weighed 90 kilograms on Earth would feel as though they weighed only about 15 kilograms on the moon. The body remained the same. The environment had changed. This simple difference transformed ordinary actions. Lifting equipment became easier. Carrying heavy objects required less effort. Yet movement also required adjustment, because the familiar balance between weight and motion had been altered. Every step became a conversation between human muscles and a new gravitational rhythm. Among the first scientific tasks was collecting samples of the lunar surface. The astronauts carefully gathered rocks and soil, placing them into sealed containers to preserve them for study on Earth. These samples became some of the most valuable geological materials ever collected. They allowed scientists to examine lunar history directly, not only through distant observation. A small fragment of moon rock could reveal information about ancient volcanic activity, impacts, and the formation of the moon itself. Inside laboratories on Earth, these quiet pieces of stone received extraordinary attention. They were placed beneath microscopes. Their minerals were analyzed. Their chemical compositions were measured. Their ages were calculated. A single rock could contain a story stretching back billions of years. The samples showed that many lunar highlands are composed of ancient rocks rich in anorthosite, a mineral type formed when lighter materials floated upward in a vast ocean of molten rock. This discovery supported a fascinating idea about the moon's earliest history. Soon after its formation, the young moon may have been partially or almost entirely covered by a global ocean of magma. As this immense ocean slowly cooled, different minerals crystallized at different times. Some heavier materials sank deeper. Some lighter minerals rose toward the surface. The bright lunar highlands may therefore represent remnants of this ancient floating crust. Imagine the moon in its earliest days, not the quiet gray world we see now, but a young, glowing sphere beneath the darkness of space. Molten rock stretching across its surface, heat radiating outward, minerals slowly separating. A new world gradually taking shape. Over hundreds of millions of years, the glow faded. The surface cooled. The first permanent landscapes emerged. The moon became the ancient companion we know today. Yet within its rocks, that fiery beginning remains quietly preserved. The samples also revealed evidence of tremendous impacts. Some minerals had been altered by immense pressures and temperatures created during collisions. Tiny glass fragments recorded moments when rock had melted and cooled almost instantly. The moon became a geological archive of events that would be difficult to study elsewhere. Earth experiences many impacts as well, but erosion, plate tectonics, and biological activity constantly rewrite our planet's surface. The moon preserves its scars. It does not forget easily. This difference makes the moon a valuable window into the early solar system. By studying it, scientists learn not only about one small world, but about the environment in which all the planets formed. The moon is like an old book, with many pages still intact. Earth is a living manuscript, continually edited by wind, water, and life. Both tell important stories. They simply preserve their memories differently. During the Apollo missions, astronauts also deployed scientific instruments designed to continue working after they departed. These included seismometers that listened for moonquakes, heat flow experiments that measured energy moving from the interior, laser reflectors that allowed precise distance measurements. The astronauts left behind not only footprints, but a collection of quiet observers. For years afterward, these instruments continued sending information home. The moon became a place where machines could patiently listen. One of the most interesting discoveries from these experiments was the confirmation that the moon experiences its own seismic activity. Although far quieter than Earth's constant movements, moonquakes occur for several reasons. Some result from tidal forces created by Earth's gravity. Others come from the cooling and contraction of the interior. Some are caused by impacts from objects arriving from space. Each vibration carried information upward from the hidden depths. The moon was speaking in a language of motion. Scientists learned to interpret those subtle signals, not with ears, but with instruments sensitive enough to notice movements smaller than ordinary human perception. Again, the lesson was patience. The moon did not reveal itself through sudden announcements. It revealed itself through careful listening. After the astronauts returned, the world continued studying the samples and measurements they brought home. The moon became familiar in a new way. No longer only a distant light, no longer only a destination. It became a place with landscapes, histories, and processes. A world with its own personality. A world that had experienced oceans of molten rock, violent impacts, volcanic eruptions, and billions of years of silence. The Apollo missions lasted only a short time compared with the age of the moon. Yet their significance continues. They created a bridge between two worlds, Earth and moon, living and ancient, changing and still. Human footsteps disappeared almost immediately into the vastness of the landscape, but the knowledge gained continues traveling. Every textbook, every image, every scientific paper, and every quiet evening spent looking upward carries a little piece of that journey forward. The moon remains above us tonight, just as it was above ancient civilizations, above explorers, above scientists, and above those first astronauts. It does not remember footsteps in the way humans remember. It does not hold stories with words, but its rocks, its dust, and its landscapes preserve a different kind of memory. A memory written in minerals. A memory written in shadows. A memory written across billions of years. And as the night deepens over Earth, the same pale light continues to cross the distance between worlds, gently connecting the ancient silence of the moon with the living, breathing landscapes below.